might look a bit tough if you take a careful look at it. There is a bent wire and the bending is in different shapes. Linear part, again linear, semicircular, quarter circular, and then again straight paths. And it's a finite length wire. Wires are of finite length. Magnetic field at the center of the semicircular arc has to be calculated. That's all. IJK directions are provided. We can straight away say that if we number these parts as 1, 2, 3, 4, 5 and 6. Magnetic field due to the second part, due to this part, 0, fourth part, 0, sixth part, 0. That means B2, B4, B2, B4, B6. These are 0 because point O is in the line of the flow of the current at whatever distance it might be. Now, about this finite length wire, the magnetic field due to a finite length is mu naught I by 4 pi d into cos theta 1 minus cos theta 2. What exactly is this? This is something like this. Now see, let's say this is the starting point A. From A to the point of reference where you want to calculate the magnetic field, if you look, there is a certain angle subtended and this angle is theta 1. How much is that? Let's look at the geometry. This is L by 2 and this radius is again L by 2. That means this length is an L by 2 length. So this net length is going to be L. This is L. And yes, if this is the finishing point of part 1, then from point B, the angle subtended at point O would be calculated with respect to this direction, with respect to the flow of current direction. And that should be 90 degree. That should be 90 degree as theta 2. As theta 2. And theta 1 is how much? Theta 1 should be equal to pi by 4, 45 degree. This angle should be equal to pi by 4. And if this angle is 45 degree, your calculation is almost done. If you say that this angle is to be pi by 4, then your calculation is mu naught by 4 pi I by d. This particular part has a length of L from here, so 4 pi L into cos of 45 degree minus cos of 90 degree. This brings in mu naught I by 4 pi L into 1 by root 2. This is your B1 calculation. B2, B4, B6 are already 0 as we discussed, and then this semicircular part. Now from this semicircular part, what we can say, at the center of a circle, the magnetic field is mu naught I by 2 into R. Now this radius is L by 2 and this is for a full circle. For a half circle, this would be equal to half of this and the radius is equal to L by 2. So mu naught I by twice radius into half is for the semicircle. This is B3, the third part, and therefore this is equal to mu naught I by 2L. Let this remain as it is. Now the fifth part, if you come to this part, the B5 value would be again mu naught I by 2 times the radius is for a full circle. 2 times the radius is for a full circle. This is 1/4 of a circle. If this is half, this is 1/4 of a circle. So 1/4 of a circle. Now this is again equal to how much? Mu naught I by 4 cancels 2 capital L. Observe this. B3 and B5 are of same value. Now the directions. Now for the directions, the vectorial directions, if the current flows like this, the magnetic field, right hand curled rule has to be used. And if the current flows like this, the magnetic field is going to enter into the page, and therefore you are going to get a crossed field due to part 1. This would be a crossed field. Due to part 3, again, if the current flows in this direction, then the magnetic field would flow and get into the page here, and you can say it would be like this, curl and then thumb. So again, this is a into the page field, and also due to this, it is into the page field. So this is again a crossed field, all into minus k direction. The crossed fields means minus k cap direction. Now, you are having all the 6 fields available, B1, B3, B5, B2, B4, B6. So therefore, the net field at point O, would be simply B1 plus B2 plus B3 plus B4 plus B5 plus B6. Effectively, what is it going to yield? The value of the magnetic field at O would be equal to mu naught I by L, 4 pi root 2, 1 by 4 pi root 2, and mu naught I by L in total, that means a plus 1 and a k cap with a minus sign. That's all. So if I compare this, I think this is the right answer. Mu naught I by capital L, 1 by 4 pi root 2 and plus 1 with a minus k cap. So therefore, you have got your answer as this, and this is the right option. And you see, we have to engage the formula in the right geometrical setup. Only then we can get the answer. Thanks for your patience, and see you in the next question. Stay subscribed and stay revised for better results.